All right, welcome to the Explainer. Today, we're jumping into a really interesting matchup: NVIDIA's legendary RTX 3090 versus the upcoming RTX 5070. This is a big one because it really shows a major shift in how GPUs are being built for AI.
And here's the thing, this isn't just about which card is, faster. It's way more interesting than that. It's really a story about two totally different ways of thinking about AI performance. You've got brute force power on one side and this new idea of hyper-efficient precision on the other. So, who comes out on top? Let's dig in. Okay, first up, let's talk about the legend itself, the RTX 3090. This card, built on the Ampere architecture, basically set the standard for an entire generation of AI work for enthusiasts and researchers. And it did that because of one huge, undeniable advantage.
And there it is, 24 gigabytes, a massive, colossal pool of GDDR6X video memory. In the world of AI, VRAM is pretty much everything. And the 3090, well, it had a whole kingdom's worth.
So what does that actually get you? What's the big deal about 24 gigs? Well, this huge memory buffer is exactly why the 3090 was the undisputed champion for so long. It meant you could just load up bigger, more complex AI models, no questions asked. You could train with larger batches of data, which can seriously speed things up. And maybe most importantly, it just gave you a much more forgiving workflow. You weren't constantly fighting to shrink everything down just to avoid hitting that dreaded memory limit.
All right, so that's the reigning champ. Now let's switch gears and look at the new challenger, the RTX 5070. And this is where it gets really interesting, because it's not trying to play the same game as the 3090. Nope, it's playing a completely different sport, and it's all built around the new Blackwell architecture. And you don't have to take my word for it. NVIDIA themselves said that Blackwell is ushering in a new era. This isn't just an update, it's a fundamental shift in thinking. It's an architecture that was designed from day one with generative AI front and center.
So what's one of the big tricks up its sleeve? Well, it's native support for new data types, specifically something called FP4. The easiest way to think about this is like a super efficient compression for AI data. It's a much smarter way to store and process information, which means you use less memory and get the job done way faster. It's all about efficiency.
And that really gets to the heart of it. The key thing to understand about the 5070 isn't brute force. It's all about intelligent, specialized performance. It's a scalpel, not a sledgehammer. You've got these brand new 5th-gen tensor cores, a huge focus on performance per watt. This thing is basically custom built for the kind of AI tasks that are exploding in popularity right now.
Okay, so we have these two different philosophies. How do they actually stack up when you put them head-to-head on the specs that really matter for AI? Let's get into the nitty-gritty.
Man, this slide just perfectly captures the core trade-off, doesn't it? On one hand, you have the RTX 3090's 24 gigs of VRAM. Think of that as a gigantic warehouse. You can store anything and everything in there. But then you look at the 5070, and it has this ridiculously huge L2 cache. That's not a warehouse. That's a super fast workshop right next to the assembly line. It keeps all the most important tools right at hand, so you don't have to keep running back to the warehouse. It's all about speed and efficiency.
Now, let's talk bandwidth. This is another great comparison. You can think of the 3090 as having a wider highway, right? A big 384-bit bus, more lanes, so the raw number is higher. But the 5070 uses the brand new GDDR7 memory. So even though its highway might be a little narrower, the cars on it are like supercars. They're faster, they're smarter, and they move data way more efficiently. So it just goes to show, it's not always about how many lanes you have, but how fast the traffic is moving.
And this right here, this is where you really see the generational leap. The 3090 has amazing 3rd-gen tensor cores. They're absolute workhorses, fantastic with the standard formats like FP16. But then you see the 5070's 5th-gen cores, and they're just built for the future. They add support for these new super efficient data types like FP8 and, of course, FP4. It's the difference between brute strength and surgical precision.
So when you lay it all out on a spec sheet like this, the story becomes crystal clear, right? The 3090 is the champ of raw capacity, more memory, more raw bandwidth. But the 5070, it leads in all the modern, smart categories. You've got that massive L2 cache, you've got the FP4 support, and maybe the biggest kicker, it does all this while using 100 watts less power. That's a huge deal.
Okay, so that's the tech breakdown, but what does it all mean for you, for your specific projects? Let's get to the verdict.
All right, let's hit the big one first. Probably the most common question out there. Which card is better for running local LLMs? Things like Llama or Mistral, right on your own PC. And for this one, the answer is actually pretty straightforward. VRAM is king, period. That 24GB buffer on the 3090 just gives you so much more breathing room. You can load bigger models, and you don't have to quantize them as aggressively, which means you get better quality.
Okay, but what if you're not loading massive language models? What about inference? Actually using a model to generate something, like making images with Stable Diffusion. What if speed and efficiency are your main goals?
Well, this is where things flip completely. For pure inference speed, and especially for performance per watt, the 5070 is just built for this. Its newer architecture, those specialized tensor cores, that FP4 support, it's all designed to absolutely crush these kinds of tasks.
And finally, the big one, the most demanding task of them all, actually training or fine-tuning a model. This is where you're not just running a model, you're building it. It eats up resources like nothing else. So, which card gets the win here?
And once again, we come back to that massive pool of memory. The 3090 is just the safer, more capable bet for training. It's so memory hungry, and having those 24 gigs means you can use larger batch sizes, higher resolution data. It just makes the whole process more stable and, frankly, less of a headache.
So here's the bottom line. It's not about which card is better overall. It's about matching the card's entire philosophy to what you need to do. If your life is all about VRAM capacity, for training, for running huge models, the RTX 3090 is still an absolute beast. But if your focus is on next-gen inference speed and pure efficiency, the RTX 5070 is really showing us where things are headed.
Now look, we've covered a lot, but this is really just scratching the surface. If you want to go way deeper, see some actual benchmarks, and get into the really technical stuff, you should absolutely read the full analysis over at bestgpusforai.com. As you can see, the link is right there, and we've also put it in the description for you.
And that really leaves us with one big question, doesn't it? Does the 5070 and its focus on efficiency mean we're at the end of the line for brute force? As AI software gets smarter and learns to take advantage of these new architectures, are the VRAM wars finally over? Is the future of AI going to be less about raw power and more about just working smarter? That's definitely something to think about. Thanks for tuning in.